This is the first video on section 7.9, triple integrals with spherical coordinates. Now, we're going to start with R being what we call a spherical wedge. And so it's a set of points rho, theta, phi with some parameters here. So first of all, rho is between A and B. A is non-negative. So that's where our rho. Our rho goes from some number greater than or equal to 0 to some other number. Theta goes from alpha to beta. Now remember, we don't want theta to be too crazy here. So theta goes from alpha to beta, but beta is less than or equal to alpha plus 2 pi. So we don't want theta to go around more than one revolution, is the idea here. A similar thing for our phi. So we have gamma less than or equal to phi, less than or equal to delta, but we want delta to be less than or equal to gamma plus pi. Because remember, in spherical coordinates, our phi was between 0 and pi. And so we don't want our phi to range too much. So we don't want the range from delta to, from gamma to delta to be too large. So that's why gamma has to be less than or equal to delta plus, delta has to be less than or equal to gamma plus pi. And so then if we integrate this, so we integrate over this wedge, f x, y, z dv, then we convert things to spherical coordinates. Okay? Remember what x is. X is rho sine phi cosine theta. Y is rho sine phi sine theta. And z is rho cosine phi. So this is just substituting our rectangular coordinates with spherical coordinates. And then when we integrated with respect to cylindrical coordinates, remember there was the r d theta? Well, we have a similar thing happening here, except instead of an r d theta, we have a rho squared sine phi. That goes with the product, so that goes with the function no matter what the function is. We have our rho squared sine phi. And then we have d rho d theta d phi. So this is our formula for integrating using spherical coordinates. So I'll step out of the frame and let this record for a few seconds just so you can see the whole thing at once.